Hi, I'm Richard Solomon, Technical Product Manager for Synopsys PCI Express controllers. I'm here at PCI-SIG Developers Conference 2026, showing off our PCI Express 256 gig PHY IP. This is designed to work with the new PCI Express 8 spec, which is coming out in the future. The spec is obviously not done yet, so this is prototype silicon, but Synopsys has historically provided prototype silicon results, characterization data and the like, to PCI-SIG to help develop the next generations of the spec. The new data rates are going to appeal to people who are looking for really high bandwidth applications like artificial intelligence, high-speed storage, high-speed networking. And right now, from what we know of the PCI Express 8 spec, it's just going to build on top of the PCI Express 7. So a fairly straightforward transition from 7 to 8, much like we saw from 6 to 7, without some of the major protocol changes like we saw from 5 to 6. But stay tuned as the spec develops and we'll see how everything goes. For more information on this or any of our other PCI Express technologies, please go to synopsys.com/PCIe.
Hi, I'm Paul Cassidy, and I'm here at PCI DevCon 2026 in Santa Clara to talk to you about our PCIe 8 controller solution with our simulation demo with link training at 256 gigatransfers per second. So I'm going to run through several screens here. First, I'm going to talk about the overall setup of the test bench. Then I'm going to run through our Core Consultant GUI and show our setup for 256 gigs. I'm going to show some waveforms with the training process from 2.5 gig right up to 256 gig. And then finally, I'm going to show the performance we are achieving at 256 gig data rates. So first we have the setup of our environment. This is just our standard test bench, which has been modified to support 256 gig. We have our controller, DUT here, with the modifications made to train, link up and run equalization at 256 gig. We have our Synopsys VIP that has had similar modifications made, and the two are linking up and training with each other. Our Core Consultant GUI has been modified to allow 256 gig Gen 8 speeds to be configured. So you can see we have 256 gig here with 8 lanes where the pipe width at 256 gig is 16 symbols or 128 bits. Moving over to the Verdi view of the waveforms, we're going through the full sequence of training here, starting out at 2.5 gigatransfers a second, then moving to the highest NRZ rate of 32 gig, performing EQ at 32 gig, moving on then through each of the PAM4 data rates, 64 gig, 128 gig, and finally to 156 gig, and we are running equalization at each of those data rates. So if I zoom in here, we start and detect, move through polling, configuration, recovery, and then we do transition recovery speed to get to 32 gig. At 32 gig in each of the subsequent rates, we're running through equalization, getting to L0, then performing a speed change to the next data rate. And we do that for 64 gig, 128 gig, finally 256 gig. When we get to L0 at 256 gig, we start our performance run. We run a burst of traffic through the controller, and we have captured the performance we're achieving at that speed. So with an 8-lane 256 gigatransfers per second controller, the theoretical throughput is 256 gigabytes a second, but in flit mode, each flit contains 236 TLP bytes out of the 256 bytes. And then there is additional overhead accounting for headers and skips, etc. So we get a overall throughput of 234 gigabytes per second, which is equal to the theoretical max. We've got no loss in our simulation here. With the ever-increasing demand for bandwidth, Synopsys is ready with our PCIe 8 controller solution. For more information, please go to synopsys.com/PCIe. Thank you.